another problem. This one's just kind of fun. And it says, what is the angular velocity omega for the electron orbiting a proton in the hydrogen atom? And I said before that this doesn't actually happen. The electron doesn't orbit like a little planet, but it's still fun to calculate and actually can be useful in some situations. So we're going to calculate it anyway, imagining that that electron is orbiting a proton. So if you recall from your previous course, if I have an object moving in a circle, there needs to be a force pushing towards the center of that circle. And we can use Newton's second law. F net is mass times acceleration. And for circular acceleration, this would be omega squared times r. You can also write that as v squared over r. So where omega is the angular velocity, r is the circular radius of orbit. And you could write that as velocity over r2, but it doesn't really, we wanted omega. So that's mass times acceleration, and this is what we call centripetal acceleration for an object moving in a circle. Now, what's the force? In this case, the force is the Coulomb force of attraction pulling those together. So the Coulomb force is K times Q1, Q2. They both have the same magnitude of the charge, which we just call E. So this is really E squared. E is 1.6 times 10 to the negative coulombs. And that's going to be over this distance between them, which we'll call r squared. We have a value for r. It's 0.53 times 10 to the negative 10th according to the book. And that's going to be equal to the mass of the electron. We're assuming the proton does not move. If you assume the proton moves, it gets a little bit more complicated, although it's pretty good approximation if this is true, because the mass of the proton is much higher. So the mass of electron, we have 9.19109 times 10 to the negative 31 kilograms. And then we have omega squared times r. And I want to solve for omega. So I can divide both sides by m and r, and I get, I don't know why I try to do right there in the middle. Omega squared is going to be equal to k e squared over m r cubed. So omega is the square root of k e squared over m r cubed. Now, let's go ahead and put our numbers in there because you will make a mistake if you're not careful. So this is going to be equal to, I'm going to put it right here, the square root of k. I'm going to not put my units. 8.99 times 10 to the 9th. E squared is 1.6 times 10 to the negative 19. Quantity squared, you see what we have there? It's getting a little complicated. And then I have the mass of the electron, 9.109 times 10 to the negative 31. And that's all times, I'll just put this as 0.53 times 10 to the negative 10th cubed. So if you do not do this correctly, you will not get the right answer, okay? But we can do it correctly. I want you to practice this. I'm going to go ahead and put this in my calculator. My calculator is getting dusty. And you can do that too. So let's just do this. I'm going to stand over here so I can see. I have to take off my glasses really quick because I can't see that. That's better. Okay, so 8.99 times 10 to the 9th. 1.6 times 10 to the negative 19th. And I'm going to square that. And I'm going to multiply those two together. Yeah, I have a weirder calculator that's awesome, but you may do it a little bit different. 9.109 times 10 to the negative 31st divided by 0.53 times 10 to the negative 10th squared, cubed. Cubed, right here. And then divided by, and then square root. And I get a number, chalk. I get omega 4.11 times 10 to the 16th radians per second, which is kind of crazy, but that's what you get. It's kind of a fun problem. The end.